Hey everyone, welcome back to the SCL playlist. In the last video, we saw how SCL can turn a multi-step ladder calculation into a single, very clean line of code. That was kind of a wow moment, right? Today, we're going to take it further. I want to give you a complete toolbox for doing math in SCL, and we're not going we're not going to use boring examples like 2 plus 2. We are going to use actually real calculations you might use in a factory or plant so you can see exactly why SCL makes life easier. And by the way, these examples are all from real situations I've faced on projects, so you know they're practical. Okay, we're still in the same project from previous video, so we have already got our data block, parameters data block with the flow calculation variables. For today, let's add a few more tags. That way we can keep all our examples realistic. Okay, let's start with motor load percentage from a motor current sensor, runtime seconds, which is accumulated runtime in seconds, torque newton meter, which is the calculated torque output. The next one, energy kilowatt hour, which is calculated energy usage. And the last one, alarm code. That is a simple integer code for alarms or status. I guess that's all for now. Okay, let's create another function here. I'll name it math operations. And the language is SCL, right? So hit the OK button here. All right. Here is our function. Let me make it a bit larger so you can see it better. Okay. Let's start simple, just to warm up. Um, Converting motor speed from RPM to RPS, which is rotations per second. Why would you care about RPS? Well, some formulas for motion control, conveyor speed, or timing are much easier in seconds than minutes. So it's a good example. Okay, let's define the inputs. I start with motor speed RPM. It's real. Also, we need an output here, which is the speed RPS, rounds per second, that I created here. There we go. Okay, in SCL, we just need to drag and drop the output here, and it's literally very simple. Our RPM just need to be divided by 60, and that's all. In ladder, you would drag in a divide block, wire it up, and make a tag just to hold the result. Here it's one neat line that you can drop right into a bigger formula if you want. And remember, the reason we start with a simple example is so we can get comfortable with the syntax before we move to bigger stuff. Okay. Just let me write a comment here. This one is example 1, and then let's move to the next one. For the next one, let's use that load percentage to get actual torque. Imagine our motor is rated for 5 Newton meter torque at 100% load. So if it's running at 60% load, that's 3 Newton meter, right? So in a SCL, we can say Let me just complete this one here. Okay, so this one in SCL is going to be very simple. Let me add a new output here. So that is torque newton meter, and then we need another input for motor load percentage. Okay, so it's going to be the torque newton meter. I just drag and drop it here, which is basically the motor load percentage. Okay, motor load percentage divided by 100 to make it a fraction and multiply by the rated torque, which is 5, and done. This is a perfect example of why I like SCL. In ladder, you need to have a divide block, then a multiply block, maybe an extra tag. Here you just write the math as you write it on paper. And the best part, if tomorrow the motor is changed and the rated torque is, I don't know, 7 Newton meter, you just update the constant. Done in seconds. Okay, let's move on to the next example, which is calculating energy consumption. Okay, all right. Time is for something more interesting, energy usage. This is something I've actually had to do for a manufacturer line where management wanted to monitor energy in kilowatt hour per shift. Um, so the formula is basically like this: energy is equal to power times time. Power in kilowatt can be approximated as torque times angular speed divided by 9550. And in SCL, it looks like this. Okay, here I add another output, energy kilowatt hour, and I need another input for torque newton meter, so I just updated the name of the output to the torque newton meter calculated, or just cal. Right. And the runtime. For this example, I just skip it as real, which is fine. Okay. So this is a formula energy. We have our torque input, or torque newton meter, times motor speed, RPM, times 2 times 3.1416 divided by 60, and we divided by 9550. Okay, so we multiply that whole thing by the runtime in second divided by 3600. Okay, I know that looks like a monster formula, but if you just read it, it's the same as the engineering equation: torque times speed divided by 9550 times time in hours. If you gave this to another engineer, they would understand it immediately without tracing through a bunch of blocks. And changing it, it's just edit one constant, not that entire network. So it's very efficient. For the next part, let's talk a bit about built-in functions, which you will use all the time. SCL isn't just about operators like plus and minus. It comes with built-in functions that save you even more steps. We have absolute value like this. We've got a square root and minimum and maximum functions, which basically pick the smaller or larger of two values, and limit, which is basically clamping a value within a safe range. For example, if we want to make sure torque never goes above 10 Newton meter in either direction, we can say basically the torque. Let me just drag and drop this one here. And yes, here's the limit function here. So the minimum value is -10 and the maximum can be 10. And we have our input here. Let me just get rid of this. All right. Yes. And also we can have the absolute value of the torque and save it in the output. Okay, let's compile this function and go back to OB1. Let me just create another network and bring in the new function here. We don't need this one and that one, and also I delete this network. Okay, let me open the data block. All right, so let's assign the inputs and outputs one by one. All right, and the last input, there we go. Here I need to create the other two tags for speed in RPS and the torque calculated value. Yes, there we go. I just drag and drop them into their places. All right. Okay, let me assign some values here. Let's say that RPM is 200, the percentage of the motor load is 30%, and the runtime is 120 seconds. Yes. And the torque is 5. All right. So here, just to get better result, I update these two tags here to show you the changes in the numbers. I use the calculated values in our functions. All right, I guess that's all. Let's run this in PLC scene. Let me monitor the okay, let me go online and monitor the values. Okay, there we go. As you can see, here are output numbers. You can see there, I'll bump up the RPM up and down, and you'll see torque, energy update instantly. Try this yourself on experiment. That's the fastest way to get comfortable with SCL. And here also you can monitor the values within the function. You can expand the outputs and see the flow of the calculations. Yes, okay, so today we built a small math toolkit for SCL, conversions, torque, energy, limits, all in real industry examples. Next time we'll use this result in if else logic so the PLC can make decisions, trigger alarms or change modes based on the numbers we calculate. Thank you so much. Thanks for watching. If you like it, hit the like button and subscribe to my channel. See you in the next one.